Share screen. Okay, let me share screen first. Okay, so let me share the screen first. Okay. All right. So can you see the screen? Okay, good. All right. Now this is the mock exam question. So I would say that I was told by the coordinator make sure that you practice the mock questions, right? Okay. So if you look at this one, right? So here you are given a signal, a discrete signal, right? Determine the even and odd component, right? And you call this even part and this odd part, right? And sketch a waveform, all three waveform. Now you see this question, right? If you see this question, you are jump onto it, right? This one is, but unfortunately, for some reason, students are not doing very well in this type of question. I don't understand why. What you have to remember, make sure you remember these two equations, right? How to find the even and odd, right? Even is xn plus x minus n. Minus n meaning reverse in time, right? You just remember reverse in time. For example, you have something like this, right? You reverse in time, this comes here, right? You flip it around, so that's reverse in time. So 1/2 of this, you add 1/2 this. Now, for odd, subtract. That's all. Okay, everything the same. You have the same here. One add, one subtract. So in this case, what's your xn? Is this, right? Okay. And then you replace this xn with x minus n, right? You put the x minus n in here, right? So change it. So that's why you end up with this. Remember this n squared plus n plus 1, right? Plus n here. You put minus n, but the square is still the same as n squared. But here, that's why it's a minus n here. You see that? Okay, plus 1. So that book, you get the answer. Now, x naught, you have this minus here. So minus plus become minus. Minus become plus, plus become minus, isn't it? With this one, get n. So what you sketch? Well, you can see that, right? This is x even, this is x odd, right? So when you add these two, even component, add odd component, you get back the xn, isn't it? So you just sketch it, then that's it. You know, I don't know how many, 30 marks, you know. Is it? Yeah, it's 30 marks. Wow. That's all. 30 marks. Now, question number 2 is like this, right? Again, you can easily sketch them, right? You know, only 3 terms, right? X minus 1, you plug it in, okay, you sketch them. So eventually you have a value somewhere, right? Okay, you can sketch it. Okay. Now, so when you check the tri-system is memories or not, obviously it's not, right? I mean, you have value in non-zero, right? So when t not equal to 0, right? This thing is supposed to be 0, right? So everything is still, but which is not true. Your HD is not true, okay? So it's not memoryless. What about causal? Well, of course, also not, because when t is less than 0, ht is not equal to 0, right? Because you see, you have a k minus 1, you put in, you end up with this side here. So again, so not causal. But stable, well, you're only 3 terms, right? When you look at the sum of 3 terms, right, obviously it's less than infinity, not infinite terms. So that's why system is stable. So again, you see this part here, again, you get 30 marks. So if you just, for this paper, you already easily get 60 marks. Now, next part is sketch waveform input-output system, input and output of the system, right? Input-output of the system. So you know that you have xt, okay? You convolve ht, right? And you get yt. So ht is already given to you here. ht is here, right? xt is what? xt again, so that's why every time you must know how to sketch the what? The scale and shifted red functions, right? It's a scale and shifted red function, which I don't want to repeat again. So you must know how to sketch it. And then you convolve ht. And ht has only 3 pulses, isn't it? 3 pulses here. ht, you look at this ht here. ht has 3 pulses, right? K equal -1 and 0 and 1. This is the same question in the tutorial. Remember tutorial, attenuated time delay, right? You through a channel, right? Your signal get attenuated, and also there will be a time delay. Except when k equals 0, right? When k equals 0, you get the original. Okay, so you end up with 3 pulses here, right? There are 3 pulses here, so like 3 pulses. So what does it do? These 3 pulses. So these 3 pulses, the first one, there's no change, right? I mean, when k equals 0, okay. So you see, when k equals 0, you have this one. Yep. And then you have one shift -1, you shift 1 plus 1 and -1, right? One shift to this side, one shift to this side, isn't it? Okay, so that's why they're free. Remember in the tutorial, so I don't need to go through this again. Tutorial, you have something like this, right? Again, you are convolving with 3 different pulses, okay? These 3 pulses, one shift, one pulse is delayed, one is shifted left, one shifted right. So that's why you end up with, I can't remember the detail, you end up with 3 attenuated, like this and like this type, okay? So this one is somewhat similar, okay? So this, so you face this kind of questions all the time, okay? So the key point is here, the key part is here. You draw these 3 terms. If you put it down in detail, let me just put it down in detail. So you have 1/2 of -1 delta t, and it's -1, you have t plus 3, okay, plus 0 delta t, okay, when k is 0, t, plus 1/2 of 1 delta t minus 3. Okay, so you see, it's just 3 terms only, very simple, right? You're convolving with any signal with delta, you're shifting by this, okay, by 3 left or by 3 right. and this attenuation. These are order. These are attenuation. Okay. All right. Questions? You stop me if you have questions, right? Okay, that is a 16 marks. Okay. Then what is question 3? Okay. Question 3. What's question 3? I look at the paper. You can know that. You know the equation. This one are the equation, the complex exponential equation given to you, meaning that xt is equal to n equal to minus infinity and infinity plus cn and omega naught t. Tell me that cn is equal to, remember periodic, right? So that's why they said that the question given to you is a periodic signal. Okay? 6t. Right? Now given xt is equal to 2 cosine 5t plus 4 cosine 15t plus 6 sine 20t, and ask you to find C1, C2, A1, A2, E1, E2. Now the problem of students is that they don't know what's 1 and 2, what's 1 and 2. This is actually you remember this when n is equal to 0, right? Here you're talking about the C0 is corresponding to what? The DC term, right? C1, we're talking about the first harmonic, you have omega naught. Okay. C2, you have 2 omega naught. C3 is a 3 omega naught. Okay. So remember when you plot the CNs, right? You always have 0, okay, 1, 2, 3, 4, right? This corresponds to omega naught. It's 2 omega naught, 3 omega naught. Okay, that's why this is a frequency, okay, or omega, okay? So this is like, okay, first harmonic, second harmonic, third harmonic, fourth harmonics, okay, that we refer to as different harmonics, right? So now this is given here. The first thing you must know, okay, you must know that is it a form that you're familiar with? Because in the class I said that in the tutorial, right? There are 3 different representations. If you still remember, we do amplitude and phase, right? And we have trickle, right? And then we also have hold on 1 second. Yeah. So we have amplitude and phase, we have trickle, and then trickle, amplitude, and phase, and we have what? Complex exponential, right? Remember, we have 3 forms, right? You must familiar with these 3 forms, very important. So now you look at this one, you see amplitudes, right? Do you see phase? Oh no, I don't see phase. Complex exponential. Do you see the exponential here? I don't see the exponential. So these 2 are not. Do I see trickle? Okay, trickle is a combination of cosine and sine. Okay, you have combination of cosine and sine. and then without the theta, right? Oh, okay. So that is a trickle form already. Wow, you should be happy, trickle form. So what you mean is that, all because it's periodic. So that means that all these are just a harmonic of each other. So then that's why you have to find the fundamental frequency first. So you have 5, you have 15, and you have 20, right? You find the highest common factor of 5, 15, and 20. So that will be, you pull out 5, this 1, 3, and 4, isn't it? Very good. So that means the fundamental frequency is 5. So that's why the fundamental, okay, angular frequency, we're talking of omega naught here, okay? So it's 5, okay? Because these are like, these all n omega naught, right? N omega naught. So it's 5. Very good. So the question asked is to find C1, C2, A1, A2, right? B1, B2. Now, remember, trickle give you AN and BN, right? Amplitude and phase give you AN and theta n. Complex or exponential, all the Cn, but n goes to what? Minus infinity to infinity. This n is only goes from 0 to infinity. This is only go from 0 to infinity, okay? So we know that this is in trickle form. So in trickle form, we know that it will give me the what? The A's and B's. Now, A0. So they ask for A1 and A2, right? A1 and A2, that means first harmonic and then the second harmonic, right? So 5, remember the fundamental frequency is 5, right? So this n omega naught, that means n equal 1 here, isn't it? Because omega naught is 5. So here is 5. So that means must be 1 times 5 equal 5. So n equal 1 here. And this one here, angular frequency is 5, right? So here must be 3 omega naught, right? 3 times 5, 15. Here will be 4 omega naught, because 4 times 5 is 20. So you have 1 here, 3 here, and 4 here. So that means this guy here must be A1, right? Because the cosine. This guy here, 4 must be A3, right? Is cosine. Now, this is sine, okay? Don't forget this sine. So, and 4. So this must be P4, okay? So this must be P4. So you know that A1 is 2, A3 is 3, and then P4 is 6. Very good. So you get all these 3 coefficients from this expression here. So what happened to other A's and B's? Other A and B, they're all 0, isn't it? Other A and B are all 0. So the question asked, what's A1? Check. Oh, A1 is 2. What's A2? A2 is 0. So that's why A1 is 2, A2 is 0. What about B1 and B2? Well, only B4 is not 0. So B1 and B2 both are 0. So B1 and B2 are 0. Right? Now, what about C's? Because A and B's you can read out from here, but C is not. Oh, okay. Remember this equation. Remember this equation. So what we're looking at C1, right? So C1 have A1 minus B1. So what's A1? Is 2. What's B1? 0. So that's why C1 divided by 1/2. So C1 is 1. C2 A2 and B2, right? A2 is 0, B2 is 0, that's why C2 is 0. That's it. Right? So see, you hardly need to do anything here. So remember this part here. Remember what are the A's, B's, and C's, and what's corresponding A, B's, and C's. That's what you need to do. Okay, good. Okay, so the D part. The D part said that, okay, xt is periodic. Okay, so it says that xt is periodic. Must be periodic, right? So, and then that one period t naught is equal to 1. So given this, okay, given t naught is 1, omega naught is equal to 2 pi over t naught, right? Okay, so omega naught, okay, because omega naught is equal to 2 pi f naught, right? Remember this, since you're dealing with f naught all the time. So f naught equal 1 over t naught, so that's why you have this. And the question is, what's the fifth harmonic of x? So fifth harmonic is okay. The question is that fifth, they didn't ask you what coefficient, it said fifth harmonic. The reason you want to see fifth harmonic, I'm looking at index of 5. Which index, A or B or C? It says that it's two-sided. Okay, spectral plot, two-sided. Meaning that you're looking for C, right? Because C can be positive or negative. So the question is asking you C5. Now in part B, student has a difficulty. They don't know what coefficient they're asking. Remember I told you, once you talk about two-sided, it's referring to C coefficient. Okay, fifth harmonic, meaning that the index is 5. So that's what it is. So in this case, you're asking for C5, right? So C5, how do you do? Well, the equation is this, right? So for one period, remember, one period. Okay, so the period is, okay, xt, xt is given to you, right? Xt is equal to plus 1 and minus 1 from 0 second to this 0.5. So this 0.5 to t to 1. So this is straightforward. So this curve is what? Okay, it's plus 1, 0 to 0.5, and then minus 1, 1. So that is your xt. Right? It's minus 1 and 1. That's given to you. So you're looking at one period. Okay. So basically, from 0 to 5, right? This one period is periodic. It says periodic. Remember, it's periodic, right? It's continuous. So you just look at one period here. So one period, this is the equation. Okay. So whole period you break into two parts. Okay. You look at from here to here, and then from here to here. So that's why from 0, 5, your xt is 1. So xt is 1. Then from 0.5 to 1, xt is minus 1, right? This xt is minus 1 here. So what you have to do is to solve these integrations. Then you get Cn. So blah, blah, blah. I'm not going to go through all this, right? You do that.
My balls, bro. Lick my balls, bro. Lick my balls.
Okay. So the question is determine the amplitude of Cn. That's C5. Okay. So that is the answer. Okay. Yeah. Is that frequency of fifth harmonic? Right. What's the frequency of fifth harmonic? Well, that's straightforward, because first harmonic is 1. First harmonic is 1. The fifth harmonic is what? 5, right? The 5 F naught. So it will be 5 hertz. Okay? That's all. This question. Okay, so now you should also go, you should also try to go through the mock exam number 2, right? Yeah. It's similar. Okay, so maybe I just quickly go through this. Almost time now. Sketch the waveform, right? This one. You see? This VT, look at this. Right? Look at this. This is just give you, remember, if you have something like this, it's always about some kind of pulses, like this. And then, in this case, it's like this, right? And then you have 3 of them. Okay? You have VT, XT, you have 3 of them. Okay? That's why XT, you have 3 of them here. And this is YT. Okay? So just scale by 2, right? Scale by 2, and there's no shifting. You see, there's no shifting. You just multiply the bottom by 2. So that's why 6 minus 2, 4, 6, 10. 30 mark. Look at this. 30 mark. Not so difficult, right? Then the next one is convolution. Now this one, some students will have some difficulties. So you must sketch it first. See all these, you must be familiar with usually scaling first and shift of the rectangular pulse. So that's why you get this one. And then here you get this one. See, all these questions are so similar. Sometimes they give you something like this, sometimes they give you something like this. Okay? Sometimes they put on the left, sometimes put on the right, that's all. So in this case, right? So when you do a conclusion, you do flip one, right? You flip, say, flip easy one, you flip this one to this side. Okay, so minus 4. Then now you put this guy here. Now you have a minus 4 here, right? Okay, you have minus 4, like this. Right? So this one. So you move this thing, okay, multiply and integrate, right? You move this toward this. You know that everything is 0 because they don't over until you hit 2, right? Beyond 2, you multiply this 2 here, then you have mu curve, right? Integration mu curve under this, right? You notice that because minus minus, you get plus. That's why starting from 2, you have an area already, area in the curve, right? And then when you happen to hit the 4, right? You have this is what? This one is minus 4 here, so this minus 4 will be something like that. So minus 4, and here minus 2. So minus 2 times minus 4, you got 8, right? It's minus 2 times minus 4, you got 8. The moment you hit 4, right, it's 2 to 4. So at this point, right, at the moment you hit 4, right, your 8, the area under the curve will be 8. 2 times 4 is 8. Okay, and then this will be 2, right? 2 to 4 is 2. So 2 times 8 is the area under that curve. Is what? Is a rectangular. Rectangular. So 2 times 8 is 16. That's why the maximum is 16 here. And this stay on, it keeps stay on, right? No change. When you overlap, you move towards this side. So until 6. And then it goes back down until 8. After 8, there's no more overlapping. That's why it all becomes 0. Right? This one all becomes 0. That's it. That's the answer. Right? Of course, you can do the integration by itself. You can do below. Okay, anything less than 2 will be 0, right? Anything between 2 to 4, you choose a t. When you do integration from 2 to t plus, or minus infinity to 2, which is 0, plus, okay, yeah, that's all, right, 2 to t, right? Then from the t to infinity will be 0, so you're looking at this part, and so you get this curve here. Okay, so you do the same thing after 4, between 4 and 6, and then between 6 and 8. Alright, so alright, I need to stop here now. So what I've done is today is I try to answer a few questions from the students, and then I pick some from the ILAs, and then also I go through the mock quiz. So make sure that you understand the mock quizzes, okay? It really helps you. Alright, so any questions?